Hey guys, Mr. Ray here. This will be our third and final lesson on solving exponential and logarithmic equations. We've had two lessons already where we explored a few different techniques, so we're going to look at a couple more here. These techniques should not be as complicated as, well, at least one of the ones on the last lesson, so these should make much more sense. Okay, so let's start off with some of these. Both of these equations are logarithmic equations. Common log of x plus 4 is equal to 1. Again, not sure what to do here. For sure, don't make the mistake of thinking this is the same as log x plus log 4. That is definitely not true. So one of the key techniques is to change the form. So if it's in log form, what would this look like in exponential form? So if I was to change this to exponential form, the 1 is the exponent, because a log is an exponent. The base, well, there's no number there. If there's no number, that's a base 10. It's a common log. So I've got 10 to the power 1 is equal to the result, x plus 4. So 10 to the power 1 is 10, and this is a lot easier than expected. Subtract the 4, we get x equals 6. And this is pretty easy to check. Plug this in, we get log of 10, and the log of 10 is 1, because 10 to the power 1 is 10. So that checks out pretty quickly. Okay. Let's try another one just like that. So this time, very similar, except this time it's a base 5 here. So we're going to do the same approach, change it to exponential form. So remember, there's the exponent, there's the base, there's the result. So 5 to the power 2 is equal to 2x minus 3. After you've done a few of these, they come out they come pretty quickly to you. So that's 25 is equal to 2x minus 3. Add 3 to both sides. 28 equals 2x. X equals 14. Okay, so that's a really good approach, changing back and forth between the two forms. So if you have a log equation and you're not sure what to do, try changing the form. If you have an exponential equation, not sure what to do, especially if you're trying to solve for the exponent, change it into log form. Okay. Now there's another technique we can use. I'll just throw this out there because I know this one is a pretty nice one. We can actually take the well, we've already got a log on this side, so I could keep that the same, log base 5 of 2x minus 3. And over here I've got 2. So can I change this so that it's the, I wanted to change it to a log base 5 of something, okay, because I want it to be the same thing on both sides. So what do I have to put in here so that basically what this says is this would be what number goes in here so that 5 to the power, so the result here is 2. 5 to the power 2 would be inside here. So 5 squared is 25. So if you were to evaluate this is equal to 2. Sometimes you have to think about it a little bit. You have to go through it. 25 is 5 to the power 2, so log base 5 of 5 to the power 2 is 2. So now we've got them both written as log base 5s. So this is kind of like when we had the same base on both sides. Since these two sides are equal, they have the same log to the same base. So therefore the arguments or the results have to be the same. 2x minus 3 equals 25. You can see that's what we had over here. So 2x equals 28, x equals 14. So slightly different approach. This one to me seems a lot more natural and straightforward, but this is something to think about as well. We ended up getting the same equation from both techniques. Okay. So 2 more questions to do here. This one, you can see complexity has gone up. It says identify and reject any extraneous roots. So that's usually a hint that all the answers we get might not be valid. So after we get our answers, see if they are valid. We had a question like that on lesson 2, where we had 2 answers and only one was valid. And it usually has to do with you can't take the log of a negative number. Okay, so we've got a log of x minus 1, subtract 1, equals the negative log of x plus 2. So what I'm going to do is put the 2 log terms on the same side and move this, at least get rid of this. So I'm going to have log x minus 1. And if I want to get rid of this, I'm going to add log x plus 2 to both sides. Okay, so I've got them both on the left side now. I want to clear out this, so I'm going to add 1 to both sides. So that's equal to 1. Okay, now here's where our logarithm laws come in. We've got 2 logs that I'm adding together with the same base. So I can combine these into a single log by taking the product, multiplying the 2 logs together. So it's like multiplying x minus 1, x plus 2. That's equal to 1. So now I'm just going to expand this. I'm going to get log of x squared plus x minus 2 is equal to 1. Okay, and again I'm going to change this back into exponential. So again, if I'm changing it to exponential form, that's the exponent. The base is 10. So 10 to the power 1 is equal to the result. Okay, so 10 to the power 1 is equal to x squared plus x minus 2. And just like that, we got rid of all the logs, and it's turned into a quadratic. So let's work with that. If I want to, that's a 10, so I'm going to subtract 10 from both sides. X squared plus x, so negative 2 minus 12, sorry, negative 2 minus 10 is minus 12, and then I get 0. We always want to get 0 on that side so we can solve the quadratic. So we cross our fingers and hope it's factorable, and it is. So we get x plus 4, x minus 3 is equal to 0. So our solutions are x equals 4 and x equals negative 3. However, remember we want to check if these are extraneous. In other words, invalid solutions. So we go back to the original equation. You notice the x is basically what we're taking the log of. So if I plug in a 4 here, this turns into the log of 3 and the log of 6. That's okay. But if I try the negative 3, I get the log of negative 3, log of negative 1. So this is extraneous. Oh, hold on. I had the wrong numbers here. Negative 4 and positive 3. Let me make this clear. X equals positive 3. Okay, so in this case, the positive 3 is fine. I get a 2 and a 5 for the logs. So this one's okay. This one obviously won't be. I get a negative 5 in here, and I get a negative 2 in there. Even if I only got one negative, it still would not be valid. Invalid or extraneous, whatever you want to say. So this is our solution, our only solution. Okay. One more question. This one looks a lot more complicated, but with a little patience and some technique, we'll get through it. So I've got the log of the cube root of this is equal to 2/3. So the first thing I'm going to do is replace the cube root with a bracket around And remember, cube root is really same as the exponent 1/3, and that's going to be equal to 2/3. Okay, so we're going to use the power law for logarithms. We're going to move this 1/3 exponent as multiplier in the front. Okay, and you can see I've got a 1/3 up front here. I could get rid of that by dividing both sides by 1/3. When I do that, I get log x squared plus 48x. So divide that by a third, it's gone. Divide this by a third. 2/3 divided by 1/3 is the same as 2/3 times 3/1. So I get 2. Okay, so when we get to this point, you can say it might not be a bad idea to change this into exponential form. I've got my exponent. My exponent's 2, my base is 10, and my result is x squared plus 48x. So that means 10 squared is equal to x squared plus 48x. Okay, obviously 10 squared is 100, so I can get that over to one side, and I've got a quadratic. Okay, and now we solve the quadratic either through factoring or quadratic formula. This actually does factor x plus 50, x minus 10. Sorry, x minus 2. So, multiply, they get negative 100. Add, we get 48. Okay, and the solutions, I'll be a little more careful this time. The solutions are x equals negative 50, x equals 2. Okay, now, again, we have to check to see if these are valid or extraneous. And we do that by subbing it back in to the original equation here. I want to make sure that this whole thing here is not negative when I substitute in my x. Okay, so I'll do it over here. So if x equals 50, I'm going to have, well, I'm basically going to evaluate x squared plus 48x. So that would be 50 squared plus 48 times 50. And that's oh, I did it again. So that's a minus 50. So that's negative 50 squared plus 50 times negative 48. So negative 50 squared doesn't make a difference. That's 2,500. This is going to be negative 2,400. So the result will be 100. And 100 would be what's inside here. Cube root of 100 is going to be positive. So that's good. That means that actually our x equals negative 50 is valid. Okay, and then we're going to try the second one. X equals 2. So we get 2 squared plus 48 times 2. And this looks very positive as well. 4 plus 96 is 100 also. So since 100, take the cube root of anything that's positive, I'm going to get a positive result. So both of these are actually valid. Okay. It's negative, it won't work, or even it's positive, it will work. There are some questions where some positive numbers will create a negative argument for the log. So you have to check. You can't just assume a negative value won't work and a positive will. In this case, they both worked, and other cases, you'll see negative works and the positive doesn't. So you never really know. Okay, so that's it for equations for logarithms. Got some more practice questions here. So again, practice will make you more confident in this. Being exposed to the techniques and figuring out which one you should use is very important. Okay, so that's it for today. Have a great day.